All right, so this is for 10.9, and we're going to start with the warm-up first. And the warm-up just has you practicing some of the other solids, like this first one deals with a cone and a hemisphere, and then we'll work with a cylinder, so just kind of putting all of that stuff together. So the first part says, a solid cone has a base radius of 5 centimeters and a height of 12 centimeters. So we need both those pieces of information in just a second. Solid hemisphere has a radius of 5 centimeters, and there's a metal toy that's being formed by joining the plane faces of the cone and the hemisphere. So that means if I have my cone like this, and I have a circular top to it, the dimensions of the cone we know are 12 for the height, so straight down here, that's 12, and the radius is 5 centimeters. Well, it's saying then that this hemisphere is going right on top of that cone, kind of like an ice cream cone. This is like a toy that is being created like this. Same exact radius for the sphere, that's why they can kind of match up, but it's just a hemisphere, that means it's half of the sphere. Okay, so this is what we're trying to find the volume of for this toy. So we're going to have to find the volume of the cone, and we're going to have to find the volume of a hemisphere. So for the cone, the formula is 1/3 pi r squared h. Right? You don't have to always start with writing the formula first, but I'm going to go ahead and just do that so that we get that, make sure we're plugging into the correct one. This formula for a hemisphere, although a sphere is 4/3 pi r cubed, I'm going to go ahead and multiply a half in front of that because we're only working with half of the sphere. And now we're going to substitute the numbers in, and then we can calculate it. And I do want to keep my answer exact here. It didn't say how to round, so I don't want to type pi into my calculator. So this would be 1/3 pi 5 squared times 12. And I'll calculate just on a calculator here with the numbers. I don't want to type in pi, so I'll just do 1/3, and then we have 5 squared, and then times 12. That comes out to 100, but don't forget about pi. So 100 pi is the volume of the cone. And I'll wait till the very end and put units, but you could do units sooner if you needed to. Okay, so then we have the hemisphere. We have a 1/2, 4/3 pi, the radius is still a 5, and then it's being cubed. And again, if you want to use your calculator, you can type everything in except for pi. So either type in a half, or I'll just type in 0.5 times 4/3 times 5 cubed. So I typed in everything except for the pi, but I get this repeating decimal. You can still write it as a repeating decimal, like if you put that little like bar on top of the 3, or if you want to convert to a fraction, you can write it as an improper fraction. That's, remember, using that math fraction button. If you can't quite see that, hopefully that helps a little bit. So it comes out to 250 over 3. So this would have a pi at the end of it, right? 250 over 3 with the pi. Or if you wanted to write it as a mixed fraction instead, you could even have written 83.3 repeating decimal like that. I'll write it like that, 83 1/3 as like a repeating decimal, or as a mixed fraction, and then with the pi next to it. Both answers are totally fine. Now we just have to add 100 to this 250 over 3, and you could either write it with the 83 1/3, so one possible answer for the toy would be 183 1/3 pi, and the units are centimeters cubed. Or if you don't want a mixed fraction and you'd rather write an improper fraction, then you can just go ahead and add like our previous answer, which was 250 to 100, which was the cone's volume, and you get your answer as a fraction again, which is 550 over 3 pi. Okay, and the units are still cubic centimeters. So I'd prefer you not to get a decimal here because there's actually going to be a part 2, but you can write your answer either of those two ways. Or a third way that you could leave your answer would be 183.3 with that repeating like bar on top of the 3 pi cubic centimeters. That's okay too. I just prefer, if you can avoid the decimals, it's usually better, just so that you're not kind of relying on the fact that it's always going to be a decimal. Kind of feel comfortable working with those fractions. All right, so then a follow-up question to this now says that A solid metal cylinder, so here's my cylinder, has a radius of 1.5 meters. Here's my radius, and a height of 2 meters. These are all in meters for right now, 1.5 and 2. And then it says the cylinder was melted down and all of the metal was used to make a large number of these toys. Because we know how much volume each one toy requires, we want to figure out how much volume will I get from the cylinder being melted down, and then how many toys could I then make from this amount of the metal, that solid metal from the cylinder. Okay, so we are going to calculate by the end of it all the number of toys that we can make from the total amount of volume, but first thing we need to know is the volume of the cylinder. Right? Here's our only problem though. This original answer dealing with the toys volume was in cubic centimeters. My answer here, if I keep using the meters, is going to be in cubic meters. So it might be easier just to convert these guys first to to centimeters, and then just you'll get your answer in the same units then. So 2 meters is 200 centimeters, because all you need to know for the conversion there is that there's 100 centimeters in a meter. Same thing here. This would become 150 centimeters because they're 1.5 times 100. Now go ahead and do your formula for cylinder. Pi r is 150 squared times 200. And then once you calculate this, it comes out to a large number, 4,500,000 pi. Because remember, we're keeping it exact for right now, and it says in cubic centimeters. That tells us that what we just found, this is the amount of metal that I'm working with, because I took that cylinder and just melted it down. This is just like liquid metal now that we can turn into these cone-like toys that have the cone and the cylinder, or the hemisphere on the top of it. So we need to take all of this amount of metal and make it into these toys that each have a volume of this. So what we need to do now is divide these two numbers. We need to take 4,500,000 pi and divide it by 5/53 pi. Okay, so let's write that out. Because this units here are in cubic centimeters. If you're ever wondering, how do I know I should divide here? Think about the units and how for every one toy you have 5/53 pi cubic centimeters, so that the cubic centimeters can cancel and your final answer will be how many toys you have, or how many toys can be made from that. So this is where you definitely need a calculator. We are typing in 4,500,000 divided by, and you can either take the previous answer and just put a pi at the end of it. Here's the good news. You don't need to put it in the pi when you type it into your calculator, because if there's a pi on the numerator of one and the denominator of another, those can cancel. That's why we wanted to keep everything in terms of pi until the very end. So if I do that, 4,500,000 divided by that previous answer, 550/3, I get how many toys here. When you go to round, think about what this means. So even though this is what I rounded to for now, I can't have 0.45 of a toy. You can't make less than half of a toy. So when you have a certain amount of material you're working with, you're going to always want to round down. Let's say you got 0.8 even. If this answer was like a 0.8 or a 0.9, still you can't round that up because you don't have enough to actually make an extra toy. So you're going to round down no matter what when it's dealing with something like trying to use material to create something, right? Because that's all the material we have to make this many toys. You can't make one toy that has half the amount. All right, so we got 24,545 toys that we can make with that amount of metal. Okay, so this is in context. We've been kind of doing these throughout with a bunch of warm-ups and stuff because you will see some of these on the quiz and the test eventually. We want to make sure we're using the formulas, just kind of applying them to find what we need. Okay, so now moving into 10.9 part of like the new part, which is density. First thing we need to know is what is density. So it tells us here at the bottom that density of an object is the mass of the object per unit of volume. Okay, what does that mean? Mass is like a weight, or it's like how much something weighs. It can be measured in ounces, grams, pounds. Those are different measurements of mass. Volume, we know, is how much space something takes up. And so that same object can take up a certain amount of space, and we measure it either in cubic centimeters, cubic inches, cubic feet, cubic meters, that sort of thing. So our units for mass, or I'm sorry, for density, will actually have two of the units kind of divided by each other. The mass and divided by the volume, because here's the formula for density. It's density equals mass divided by volume. And remember, you don't have to memorize this, but it will be provided to you. You just have to know how to work with it, how to use it. So this top, you might also see it abbreviated. If you ever see it like density equals M over V, that's just another way of saying the same thing. Another way to write density is by using a shorthand, a Greek letter. It looks like this. It's kind of like a P, but it's a little more like slanted or cursive almost. This letter is pronounced rho from the Greek alphabet, and so it's a Greek letter for density. You don't have to memorize it. Usually I'll just include these in for like tidbits of things because you may see it in a future math class, but you are not expected to have to write it this way. On a, like on the final exam or on the test, some of it, if you see that this shows up, then really you should be able to identify that that's density. Okay, so just main idea, make sure you just know that formula, or know how to work with it at least. If not, you don't have to memorize it yourself, but at least just working with that formula. So let's try one out. This first example says, the United States Golf Association specifies that a golf ball must be spherical in shape, so it tells us it's a sphere, and is to be no less than 1.6 inches in diameter. Find the density of a golf ball if its mass is 45.93 grams and its diameter is 1.68 inches, based on the rules of the United States Golf Association. So if we know the diameter, we can find the radius. Just cut that in half. And we can also find the volume of the golf ball because the sphere, right? So we're going to do volume of a sphere formula, 4/3 pi r cubed. And I'll go ahead and substitute in my r that I just found, 4/3 pi 0.84 cubed. And just use your calculator. You can type in, and you don't have to do exact answer on this one because it's already got to deal with a lot of decimals already. So this comes out to approximately 2.48, I would say 27 at least. I would say get at least about 3 to 4 numbers after the decimal for right now, since we're not quite done. We want to finish this problem and not round too much. So then my final answer here, using that formula, if you want to use that symbol for density, O is equal to mass over volume. We just found the volume because we need to plug that in for V, and the mass we're going to plug in for M. That's all we're doing here. So this would be this rho or density equals 45.93 divided by 2.4827. And depending on how you rounded, your final answer may be a little bit different than mine. Think about the units here as well. This is grams for the numerator. The denominator was in cubic inches. So our final answer for density is written like this: grams per cubic inch, or with the little fraction bar, grams divided by cubic inches, and the answer comes out to about 18.5, or you can put a 0 after if you wanted to, but this is what density equals. And we're done.